So this is the option I went with, at least with BrainCreds and BuzzyGo and some of the other things that I'm working on the side. And I like it. And the main reason I like it is that I have sort of this insurance layer here, this Azure subsystem insurance layer between my web role and my worker role. So without this, I kind of have my web role just talking straight to my command handler through a WCF service, let's say. And if for some reason the worker role were ever to go down, basically I need to have some level of exception handling in there to say, hey, I can't communicate to the backend service. Try again in a couple minutes or something like that. And so that's not a great user experience, and I didn't want to kind of keep going down that road. So I decided that I need to be able to queue up those commands so that if the worker role were to go down, at least the user experience isn't being adversely affected in terms of they're either getting the yellow screens of horror or hey, try again later, we can't communicate to the system, and all your information's been lost. So at least with this approach, while the queues aren't transactional, at least it can be a storage mechanism so that I can drop the command in the queue, and if the worker role were to go down, that command's not lost. It'll eventually be picked up and processed when that worker role comes back online and starts processing. So what's really happening here then is within my controller and within that queue command method is that I take my command object and I serialize it. I serialize it down and I drop it into blob storage because a message queue or a queue in Azure in an Azure queue is limited to 8K in size. And so if I'm creating a lesson or if I'm creating something that has a lot of text or attachments or whatever that might be, it's very possible I could go over that 8K limit. Now, I could put some smarts in there to figure it out and say, okay, it's under 8K or it's over 8K, but I took a fairly dumb approach to it and just said, you know what, for right now, I'm just going to put everything in blob storage. And so what I do is I create a blob container. I drop my command in blob and in the blob storage, and I essentially have that blob ID when I create it, and then I create a queue message and put my blob ID in that queue message and drop it in the queue. So now I have my worker role running back here, and it's monitoring the queue, and it's saying, do I have any work to do? And eventually, when it wakes up and it looks in the queue, it sees that it has the queue message in there, picks up the queue, and says, oh, I have a command I need to process, and it's in blob ID 2, although it's something good. So it takes that queue message out, deletes it, pulls the blob out of storage if it's there, and deserializes it into a command object, and then at that point drops it over to the domain, and then it processes through its normal pipeline all the way down to the read model. And at the same time, the command handler can also do any logging or anything like that. It's Azure Table Storage, or if it's handling any of the events also from the domain could also be going into Azure Table Storage. So this Azure subsystem sort of in the middle, I call it a subsystem, it's probably not really, kind of gives me that layer of I call it a protection layer, but it's also sort of that loosely coupled layer too between the web role and the worker role, and allows kind of that user experience to be pretty good, and it gives me some level of fault tolerance, although it's not 100%, at least it's some protection from abnormal behavior on the worker role. Now, if the web role goes down, then all bets are off. That's that. See, I don't know if anybody's laughing at the jokes I say or not, or if anybody's even listening or not. That's the downside of a live meeting. Nobody knows. So anyway, this was the general flow as I kind of walked through it. So again, the web role is issuing the command, it drops it in the blob container with a GUID, and eventually works its way through the queue over to the worker role. Worker role picks it up and then drops it into the normal CQRS pipeline, and everybody's happy. So again, the nice thing is you do have that web and worker role separation. Kind of talked about the level of fault tolerance. And then the nice thing too is that worker role can spawn multiple threads to maybe monitor multiple queues, or you can have multiple worker roles monitoring multiple threads or monitoring multiple queues and that kind of stuff. So let's just take a real quick look at what's going on, at least within my worker queues, or within my queue monitor. we can see what's happening here. So queue monitor. So this is my role entry point. My role entry point for my worker role. So what's happening is I do a little bit of just logging just to make sure things are running happy. And the first thing I do is I kind of spawn off a separate thread using a timer, which may or may not be the best way to do it, for my logging. And so my logger has its own queue that it's monitoring, and it's going to pull every 10 seconds because I really don't care if the logs are up to date. I can make this a minute for all I care. I just want to be able to know what's happening. This while loop, while true, is sort of a out of the box standard infinite loop that usually see on the MS Dan examples. So it always scares me to see while true. But anyway, so this thing is constantly running, and what it's doing is it's waking up my command queue puller. So this is the one that's actually looking at a specific queue just for my CQRS commands to process. And if it finds any, it's going to process them and then go back to sleep for 2 seconds. I will say, this is a funny aside. When I first started working on this, we had first gotten our BizSpark licenses and got everything set up in Azure and everything. And I kind of put a real quick polling mechanism together, and I probably didn't research my Azure polling and costs a whole lot, but I didn't have this line in here. So what happened was we turned the service on, and we deployed it out to staging or production, whatever it was. Tested it out. Hey, it was working great. Things were really speedy. It worked great. And my co-founder was like, so this is going to work, right? I'm like, yeah, no problem. And in the back of my mind, I'm thinking, okay, the Azure pricing is a little complex at times, but I think I have a handle on what's going on. And it's embarrassing to admit it, but I think it's still pretty funny. So as a BizSpark member, at the time, I think we had 1,000 or 1 million transactions a month that you're allocated as part of your BizSpark membership. And in my mind, I'm thinking 1 million transactions. That's great. I mean, we're never going to hit that. And so I turned the service on at night. I went to bed. I woke up the next morning. I wanted to see, did we have traffic? What's the what was our usage like? And actually, the Azure billing system is actually pretty cool in that they give you not real-time stats, but maybe every 6 hours or 12 hours they update your usage. And so I checked, and within that 14 to 18-hour period, without having this sleep in there, this guy generated something like 8 million transactions within that period of time. So I had already burned through the 1 million transactions a month that I was given through BizSpark within a 14-hour period, and incurred another 7 million. And it cost us like a whopping $5 or something like that. But still, I was kind of kicking myself in the pants because I let that happen. So the moral of the story is definitely check out how often you're polling and keep that in mind. Learn from my mistakes. So anyway, long story, but I get a laugh out of it. Hopefully somebody did. So the command worker is going to handle the monitoring of the queues to see, or my command queue to see if there's any work to be done. So if I take a look at command worker, what's going on here is it's doing some very basic queuing logic with the Azure API and along with working with the Blob API. So again, I have my command queue that I'm working with, just straight Azure queue. I'm getting the message off that queue. It's a Cloud Queue message. I'm checking to see whether or not it's null. If it's not null, then I know I have something to work with. I get the blob ID out of that message. I go ahead and delete it off the queue. And I split it apart because I have a little bit of information in there. And I then take that ID out of that queue. I go out to my blob container. I say, give me this particular blob with this particular ID. I get it back. And I deserialize it, and essentially I now have a CQRS command that I can then hand off to my domain. And the nice thing about NCQRS is that it kind of gives me a little bit of that framework that I can play with. So I have that object that comes out of my blob container. I basically convert it from just a straight object to a base command type, to the command type that I'm expecting, and then I just take that command and drop it into my CQRS service handler. And so I let the CQRS framework kind of handle routing that command to the right domain object. And that's kind of where that framework comes in handy. I could write that, but I think they did a decent job in terms of routing those commands to the right objects. But in essence, this is really what's happening, and that's the crux of it. That queue worker, that's all it's doing is just checking the queues, seeing if I have messages to pull out. It pulls out the ID. If there's an ID, it goes into the blob container, gets that blob out, deserializes it, casts it to a CQRS command type, and then drops it into the CQRS pipeline, and everything else basically just works. I then call the queue again, see if I have any more messages to process, and if I do, it keeps looping through until I'm done with messages, and otherwise I'm done, and I basically wait for that 2 seconds, and then this thing wakes up again. Probably a best practice would be not to read each message at a time, but try to get a batch of messages in to kind of keep your transaction count down. But since I just threw this demo together pretty quick, you can kind of see and kind of watch each demo kind of happening. So I can show real quick here what's going on. If I bring back my BuzzyGo demo here, yeah, this is the local one. So I want to go ahead and create a card. So if I bring up the emulator, the compute emulator, so you guys are seeing everything. If it comes up, come up. There we go. All right. So I have kind of this compute emulator running. I have two roles here: my queue monitor here and my web monitor, or my worker role and my web role. So I'm watching my worker role right now, which is the queue monitor. So every 10 seconds, that logger is kind of going out. Do I have anything that needs to be logged? No, I'm going to go back to sleep. So that's kind of what you're seeing happening here right now. But if I go back to BuzzyGo, and decide to create a card, and I flip back to my compute emulator, the logger should wake up, and then it'll say, hey, this user's about to create a new card, and the user got a new set of random buzzwords. So not only am I using my queues to handle just commands being issued in my CQRS system, I'm also using my queues to handle some user interaction logging. Not so much what actions happened on the backend system, but what clicks, what things did the user do, so I can almost recreate a user's action over time. So I create a separate queue for that. I create a separate set of commands essentially for that, but I'm handling them in a slightly different way. And I don't care if I pull them out every 10 seconds or 60 seconds. It's historical information, but at least I can see what the user's clicking on and what that user's doing. So let's keep going through this because I think I have about 5 or 10 minutes left.